G'day Internet and welcome to River City Ransom Underground. My name is Andrew Russell and I'm the lead programmer on River City Ransom Underground, and in this show we talk a little bit about some of the technical features in River City Ransom Underground. So today we're going to have a look at the Heightmap system in River City Ransom Underground, and what that is it basically lets us declare the shape of rooms and objects that we place in the rooms. So you have a good idea about their physical layout. So we can obviously jump on top of them, we can go behind them, we can go in front of them, we can collide with them like so, and so on. So if I switch into the debugging system and I can bring up this Heightmap debug overlay, so you can see in the sort of top corner that's the solid view and it overlays over the top, and I have a key here that will let me do a solid overlay over the world, and let me just add to that by activating object outlines. So you can see here that Alex is this blue square here, and you can see that the blue rectangle for Alex will jump on top of these height maps, and we'll collide with the sides and the front and the back and the front and so on. And then I just ran into it, so it's recovered. And so if I come over this way, you can see there's a very high wall to represent some impassable sections, so you can't jump on that because we've blocked it off. Here's a crate that I can pick up. If I aim, I can kick it. So if I pick up this crate, you see the height map comes along, and if I do this blind, let's see if we can bring our two characters together. Where have you gone, Glenn? Oh, I don't have Glenn's controls activated. So I have a height map here, and I bring Glenn over, and let's do it without that overlay. There we go. So he can stand on that height map while it's being carried around by Alex. And then we come over here, we'll get rid of the box, send that over there. So over here there's some more height maps, and then you can see over here there's an entrance to another room, and I won't go in there, but you can see I can travel into the entrance, and my graphic system is occluding me over there, which is a different system, but still, and so on. So that's sort of a general overview of what the Heightmap system does for us. It lets us basically define the physical characteristics of objects in the scene, and the scene and the room itself. So if I get out of that one and let me bring up the editor. So let's have a little talk about, in fact, actually, let me bring up the whiteboard. So let's have a little talk about, and you'll see I've got the color wheel here now, so this is going to be improved on the last couple of videos, so I can change color on the fly. So let's say we have an object. Let's draw ourselves a nice sort of, let's draw an arcade cabinet. So an arcade cabinet looks a bit like this. And there's amazing art skills. Let's say it looks like that, and then if we can see through it, it forms kind of a box situation, and so on. So the Heightmap system basically is a thing where we take a section, we take a exactly sized bounding box of the size of the objects, and obviously this is divided up into pixels, so we'll just pretend it's divided up like so, and this way, and then for each point in this sort of pixel in the height map, essentially, we then, let's change color to something a little more purple. We say, this pixel, all of the pixels along here, and all of the pixels along here, pixels in this area have values of this height. Let's say this is, I think it's about, let's call it 63 high. And then the ground, of course, is 0 high. And so the pixels here are the pixels here are 63 in this middle section, and then the pixels out here, let's say this is going to be a different color. The pixels here are going to be 0. And when this is an object in the engine, well, in fact, yeah, if this is in the engine, the interpretation of 0 high is that you can walk through it. There's no object in that location. So if we then project what this looks like, we then get a box. We'll do that in a different color to make it more clear. Let's say it's green. I like using the colors that the engine uses, but now I've used up too many colors. So if we project up that section 63 high, comes up to there, this comes up to there, and we get what is essentially a box. So we don't have to model this this bit in here, this like cutout, because nothing can go in there anyway. So we have this 63 high section, and then of course if we have a character, he's very happy about the fact that he can stand on that. So, and then finally, just to get a little more technical, this here is stored as a byte array, and it does have dimensions, but it's stored separately. Technical details. But yeah, so it's a byte array, so its values range from 0 to 255. So there's a special value of 255, and that is what you saw. I'll bring up the game again very quickly. Just here, and this section here, you'll find is 255 high section, and that's a special value that we use that's basically means that it is infinitely high and characters can't walk there. And I just realized that I'm now drawing behind myself, so I'll just move. In fact, I can scroll this way. So there we go. So the values in the or I can zoom out, I guess. The values in the height map range from 0 to 255, and 255 is a special value that's basically infinite high and unwalkable. Okay, so that's sort of a overview of the way the height map system works, and we're all very pleased about it. Now, so if I come into the editor now, and we'll see we have a barrel. So in the editor, I can turn on the height map. There we go. Voxel rendering, I can adjust the opacity of that layer. So here's a barrel with a height map. And the way we sort of draw these height maps, we don't obviously sit and say, this pixel is 63 and this pixel is 63 and this pixel is, and go through all the pixels like that. That would take a very long time. What we do is, say we have a barrel, we're going to right click and edit height map. And so we have a series of instructions, and this one just has one, and that is set from flat top mask. So if I were to open up the mask and turn on the mask rendering, you'll see that I've defined this circle here. So if I say edit it, and I can just cut out that edge and save it, you'll see that edge has been cut off, that edge has been cut off there, and the height map then doesn't extend past there. So I can edit the mask, I can edit the height, so I can make it taller, I can make it shorter. Now you'll notice that it's extending from the top. So I forget what height it was to begin with. It's 25 to begin with. So it's extending from the top here because that's set from flat top mask. So we have a number of different instructions. So set from flat base mask, you'll notice it's flipped around. So it now thinks that the mask is defined to be at the bottom. And so what I can do is I can just simply take my mask and I'll just drag him down here and save. And so now it's the same mask except it's defined from the bottom. So just to give you an idea what that looks like, how can I clear this? That was black. Let's go for white. There we go. So just to recap, so if we define a set from flat base mask with a height equals 25, it will shoot that up and fill that in as if it's 25 high. Whereas if I set a from top mask, I draw this mask here, and if I set the height equals 25, it will then work out, basically, it will assume that's the top of an object and do some maths and figure out where the base should be and ensure that the values in the pixels in the height map, which is always declared as the bottom of an object, it will fill those in and say those are 25 high. So we have a few other instructions. So I've got the car here. Let's edit height map on this fellow. So this uses something called set from front edge. And so the mask here is very hard to see. You can see there's a, bring it full opacity here. Can I change the color? Yeah. So you can see it's this line along here. This pink line now. And so what that is we define the front edge of an object. And then using the parameters, we can adjust, for instance, how deep that goes. So if I can make it deeper, whoa, I can make it very deep. I can make it shallower. So I've just got half a car there. And I forget how deep that was, but it'll do. And I can also adjust the slope. I can also adjust the angle. So I can make it fold to the right instead of to the left. I can also make it go straight back, which, yeah, so it's a little hard to see because it covers up the darker sections. Let's just close out of that for a second and bring the voxel renderer up to full opacity so it's a little easier to see. So I can make it straight, I can make it tilt to the right or the left. I can bring the depth down. I can also change the slope, which I'll show you in another video why we have this feature, but it is a cool thing we can do. So 2, 3, 1. So normally for most objects we leave that set at 1. So, you know, in the game, the car will obviously look like that, but when you go to collide a character with the car, it'll look like this. So yeah, and so it's very easy to just draw just the front edge like that here, and then use the parameters to shoot that out. So I have another one. This is the porta potty. Okay, so here's a little demonstration. This height map has been baked, which means there's no instructions. The height map's still there, and I can that's because I'm editing the height map. If I edit the animation, maybe I lied. Maybe that's a bug in the editor. It might be a bug in the editor. So it does have a height map, and you can see that because I can't create one. I can delete it though. Oh, I know why there's no height map, because you can actually see the height map is here. So this one might be a bit tricky to demonstrate because it's actually got a different origin. There's an old piece of data from before we changed the origin. So let's delete that height map and let's see if we can create a new one. or we can crash. So we tried. So this is one of the wonderful things about not scripting these videos, is that sometimes that happens. But let me demonstrate what that one looks like. So it should be fairly obvious what this will do based on the description. So we start, let's draw the mask in pink. We start with, actually, tell you what, let's actually draw out our Portaloo. So it looks a little bit like this. So this is a fairly unusual object in the game, because rather than sloping off backwards like the car, it sort of has its flat edge to the side, and there's actually some curvature here at the top. There's only a couple of objects in the game that do this, but we have a few, so we had to make this height map instruction mechanism for this object. So what we do is we draw basically the flat surface of the object with the mask, and the engine then does some maths, and it basically calculates out what that height map will look like. So it effectively projects it back as far as we like. It projects back the depth and fills that in, and the end result is that down here we end up with a height map that has so say let's say that's all let's say the height map is in here, and we'll clear that out. So it will fill in the this section here with heights, and the heights will be the tallest here, and it will be, you know, slightly less tall here, and it will sort of curve away. And obviously that's a little hard to draw in 2D, sort of flattened out, but there's basically a sort of curvature in the data going this way. And then as before, the rest of this in here and in here is 0. So that's how we get objects that sort of recede that way, rather than ones like the car that will recede sort of in an oblique direction out to that way. So that is the that's another height map instruction that we have for specifying height maps. We have another few, so let's clear again. And so there is an older one. We don't use this one much anymore because it kind of causes problems. So let's say we have a car like this. Fantastic drawing situation here. And what we used to do, the first attempt at doing the car, is we'd basically color in the whole top surface. And what the algorithm would do is it would essentially search for this front edge here. Let's try the different color that actually contrasts. We'd search for this front edge here, and it would work out how far to go back. So rather than specifying a fixed depth like the set from front edge depth, it would actually look back at the pixels in the mask and say that's how deep we want to go now. This ends up not working very well because we actually typically want this to all be the same depth. And you'll have noticed when I play, if you like really observant, you'll notice that when I place down a car in some of the older videos, that the you'll notice that there's like a few pixels here, a few pixels here that like stick out further, and that's because obviously there's a subtle slope to this front of the car. It's not exactly flat, and the back half, you know, the back half might look like let's demonstrate. The back half might look like that, then that, then that, then that, then that. Whereas the front might look like that, then that, then that, then that, then that. And what happens is these don't line up perfectly. So, like, in fact, I've lined them up perfectly. Let's say it looks like, let's say the front of the car has some pixels that look like this, and then when it goes to line them up, the graphic doesn't match exactly the thing, and what you find is that this section here, in this section here, is longer than this section here, this one there. So we get weird depths, and so there's like this bit sticking out there. So we've fixed that, and we don't really use that option anymore. Then finally, clear again, and there's there is a set from railing mask, which basically takes, say you've got a staircase railing, and you just draw out the picture of it, and that creates a sort of height map with 1 pixel of depth. So in that direction, it's 1 pixel, and so that's good for stairways, railings, and things. But it's more or less the same as set from front edge depth that just grabs the pixels here and here, and then lets you project it out any depth that you like in that direction. So basically that's how we make height maps. They're built up from a series of masks like this, and a few parameters like depth to go backwards, and you know, for the barrels, and sort of very common objects like how high that object is. We also have set from flat relative, which is basically a variation on this one. So say we had a landscape and we'd set this to some value, then we'd want to draw a mask in the middle and use that to, like, we'd carve out a hole. So we'd set that height equals negative 50, and so that would cut out the hole while still allowing us to draw the mask on the surface, because obviously these all have to be created by an artist. So if we've got to draw an object, we actually want to be able to draw on the surface. That's why we have from top, because it's actually a little bit tricky. If we wanted to draw from bottom, we don't use this one much, because you have to work out the curvature of this object, but really you can see the curve at the top. You can't see it here because it's occluded by the object itself graphically. So yeah, so that's how we make our height maps in River City Ransom Underground. And then the game crashed before, which is great. That allows us to do all of our collisions. So thanks for watching, and in the next episode we'll talk a little bit more about some interesting things that we do with height maps, aside from this, a few special corner cases. So thank you for watching, and I'll see you next time.